Hello, wonderful students. Welcome back to another day of chem. If you hear squeaking in the background, it's because my dog Bailey was just going to town on a toy. So I think she's stopped now, but we'll see what happens. So anyway, today we're going to be working on the ionic versus covalent bonding one-page assignment. So I have different versions of the assignment depending on the semester. So a couple things that we should recap on first is just what's the difference between ionic or covalent? Because what you should be doing is anytime you formula to naming or naming to formula, you should make sure that you are first determining ionic or covalent, like everything you do. Easiest way to do that here, I'm just going to hide the periodic table for a minute because we don't need it. Actually, maybe I'll just scroll this over. So easiest way to do that here is to just remember ionic have a metal, or realistically we should probably say ionic contain a cation, and then covalent, oh, I wrote that over a little too far, and then covalent contain only nonmetals. So that's the easiest thing to look for as we're doing any of this. So if we go through and keep those in mind as we work on this assignment, it makes our lives a lot easier. And then there's some extra rules that we, could probably add on to here. So ionic, an important thing to remember is that you need to balance charges. Because remember that word ion, like literally ion, ionic, means contains a charge. So it has gained or lost electrons, so you need to balance charges. And then covalent, you use prefixes instead of balancing charges because charges don't apply because they're going to share electrons. So anyway, if we start working through question number 1 here in these true and false questions, ionic compounds contain a metal. Well, that's true. That's actually the first thing we just talked about. So if we look at our periodic table here, on the right side, we can see that metals are our pink and our green elements. So ionic compounds contain a metal. That is true. And when we did that compound inquiry lab, that's why you could see things like ionic compounds did things like conducting electricity. So ionic compounds dissolved in water conduct electricity. Ionic compounds contain a nonmetal. Actually, that one is true. This was meant to be a trick question, but while they do contain a metal, they also contain a nonmetal. Simple example would be like your table salt. So your table salt, just remember, is NaCl, so that is sodium chloride. So that is, it contains a metal, sodium, and then a nonmetal of chlorine. So it does contain a metal and a nonmetal. Covalent contains only nonmetals. So if we go on to question number 3 here, covalent compounds contain a metal? No, that is definitely going to be false. If it contained a metal, it would have been ionic. Covalent compounds contain a nonmetal. That's true. They contain only nonmetals. Covalent compounds transfer electrons. This one is going to be false. The way I always tell students to remember this, remember that word co. Co literally means to share or to work together. So they're going to share electrons. They don't transfer them back and forth. True or false? Ionic compounds contain charges. Yep. Remember that word ion. Ion literally means charged atom. So that is, it has a positive or a negative charge. And then true or false? Both ionic and covalent compounds have the second element end with I. That is absolutely going to be true. They both do, just like I could give you the ionic example again of your table salt, so sodium chloride, or your covalent example of carbon monoxide. So they both end in that IDE ending. Coming down to question 2, in ionic compounds, the blank is always written first. We can answer this again in 2 ways. We can either say the metal, so again, like sodium chloride, or we could say the cation. So I would accept 2 different answers here. You could say metal, or you could say cation. The positive charge is always written first. Ionic compounds contain charges because the elements have, and this is an important thing to understand, goes back to gained or lost electrons. Again, sometimes we'll say the word transferred electrons instead. So we'll kind of use gained or lost interchangeably with transferred electrons. In covalent compounds, which prefix will you never put on the first word? Again, we can actually see that example up here. Carbon monoxide. Well, carbon monoxide is CO. So 1 carbon, 1 oxygen. But you'll notice we don't say carbon monoxide. It's just carbon monoxide. So you never put that prefix mono on the first word. You can definitely put it on the second word, but not the first word. All right, continuing down to question 5 here. So I was trying to get my periodic table in a way where it's not in the way. Identify whether each element is ionic or covalent. Again, that's the first thing you should do. In fact, I'm not even going to do this one question at a time. I'm literally going to go through and do ionic or covalent right away. I'm just going to get myself into that mindset of determining ionic or covalent. It makes my life a lot easier just to strategize this. So looking at question number 5, just remember, easiest way to tell, just look at the first element, determine if it's a metal. If first element is metal, because remember it would always be written first, so if first element is metal, it is going to be ionic. So I'm going to look at this first one here. I see lithium. Is lithium a metal? Yes, it is. It's one of our pink or green ones on the periodic table. So that's going to be ionic. Look at the next one, Mg, magnesium. Hey, magnesium's a metal. That's going to be ionic. Potassium. Potassium's right here. It's a metal. That's going to be ionic. Phosphorus. Phosphorus right here. Oh, that's yellow. So that means that this must be covalent. CO2. That's carbon. Again, please note that they're both capitalized. So that means that this is carbon and oxygen. It is not cobalt. So that means that this is covalent. We see Al, so aluminum, ionic. CCl4, again, carbon first is a nonmetal, so that's going to be covalent. Coming over here, potassium. We know from before that that is a metal, so this must be an ionic bond. Barium is down here, so barium is going to make this ionic. Magnesium is metal ionic. Gallium ionic. Carbon tetrabromide, so covalent. Nitrogen, we haven't done yet, but we can see that nitrogen is a nonmetal, so that means that this is covalent. And then calcium phosphide, calcium is going to be a metal, so that is ionic. All right, and those rules are important. If you need help on how to do this, I'm going to go through this quickly, so you would need to make sure you go back to the previous assignments or the previous videos and rewatch those if you need help specifically on ionic or covalent, because I'm going to be going through these fairly quickly. Naming ionic is really easy. You're just going to write the name of the metal, so lithium. Sorry, my iPad seems to be glitching a little bit. And then oxygen becomes oxide. Life is good. Another one's ionic, so I'm just going to write the name. Magnesium. And then Se is kind of a weird one. We don't work with that one a ton, but you can see Se is selenium. So that just becomes selenide. KBr, so potassium. Br is bromine, becomes bromide. And now we notice covalent. Please remember, covalent need prefixes. Wow, my iPad is really glitching. So with this, I see 2 phosphorus. So this is where you actually have to go to the back of your periodic table. So we have to go down to the second page and we can see our prefixes here. And we see 2 is di. So that's going to be di, and then it says, and we still don't change the name of the first one, so it's just going to be diphosphorus. And then 5 is penta, we can see. So that's just going to be pent oxide, because oxygen becomes oxide. CO2, so this is where students are going to be tempted, right? That means 1 carbon, so students are going to be tempted to say monocarbon, but as we saw earlier, if I go back to our example, you don't put mono on the first word. You can put mono on the second word, but not the first word. So we're just going to say carbon, and then 2 oxygen is dioxide, and that's the gas that you breathe out or is in your Mountain Dew or whatever carbonated drink you have. Next one, Al2S3, but we're back to ionic, so we don't use prefixes. So these are pretty easy to name because it's just going to be aluminum sulfide. CCl4, it's covalent. Again, I don't put mono on the first word, so this is just going to be carbon. And now our prefix for 4 is tetra. So it's going to be carbon, tetra, and then chlorine becomes chloride. And that's how we practice our naming. For these next ones now can be a little bit trickier. So this is where we need to make sure that we're balancing our charges. So in order to balance our charges, I'm just going to run through this quickly. Potassium we can see is a +1 charge. We can see that iodine is a -1 charge, so this one's pretty easy to balance out. But we only do that for ionics. So this formula to balance, we only need 1 of each. Potassium iodide. Barium sulfide, barium is a +2. And I'll look at sulfur while we're over here. Sulfur is a -2. We can see that barium down here is a +2. So again, for those to balance out and be happy, this is just BAS. Magnesium chloride. Magnesium's +2. Chlorine is -1. So in order to balance these out, I'm not going to be happy with just 1 of each. We're going to need another chlorine. So we need to make sure that this formula is balanced, so MgCl2. Gallium oxide, gallium is +3, oxygen -2. So in order to balance those, I would actually need 2 galliums, 3 oxygen. Again, if you need help with this assignment is more review. You should be going back and doing the previous ionic assignments. Now we're into covalent, so we don't worry about charges. We actually said that back up here. Charges is only for ionic compounds, not covalent. So to balance to do this one, I just follow my prefix of tetra, and since there's no prefix on carbon, I can assume just 1. So this is going to be CBr4 for tetrabromide. Dinitrogen, so N2. Pentaoxide, O5. And then calcium phosphide. So I need to balance my charges. Calcium's +2, phosphorus is -3. So this is going to be Ca3. I'm going to need 3 calciums to balance out 2 phosphorus. And now coming down here, just to draw these really quickly, magnesium has 2 valence electrons, oxygen has 6 valence electrons. Remember that every single electron is a bond that wants to be made. Since this is ionic, electrons are going to transfer from one to the other. I'll label my charges. Life is good. For covalent, they're going to share the electrons, so I draw it a little bit differently. Hydrogen has 1 valence electron. Hydrogen has 1 valence electron, so they are going to share the electron. So I'm not going to draw an arrow, but it still holds true that every single electron is a bond that wants to be made. And there you go. That's ionic versus covalent. Thank you for learning with me. If you have questions, please feel free to email.